Hello, today we will discuss about how to integrate this kind of equation in Python code, and we will see the effect of this problem. In that, there are plus system flow is showing in this figure. There are one driving shaft and one is the driven shaft. In between them there is one SAE 30W oil is there with different thickness. We have to find out what is the minimum thickness we have to require, and what is the determine the transmitted torque by this lubrication effect. So first we will derive this equation. Now I will say, first we will assume there are the one disk is rotating in same direction with omega 1 and omega 2. For finding out the torque, we will assume that one of these disks is stationary, and so final our rotating speed is omega 1 minus omega 2, and the velocity gradient v is equal to omega 1 minus omega 2 multiplied by this r radius. This is our tangential velocity, and our wall shear tau is equal to mu du upon dr. So mu, this v, and this is h. R means our h, sorry, this is dr. So mu v, we know that omega 1 minus omega 2 multiplied by r divided by h. So this is shear. So shear force will be dF is equal to tau multiplied by d area, means minimum force acting on this smaller rectangular face is equal to dF is equal to tau dA upon tau into dA. So tau is equal to mu omega 1 minus omega 2 multiplied by r divided by h, and this area is equal to 2 pi r into dr. This is dF. Now we will find out the torque. So dt is equal to dF multiplied by r. This is torque. So dF, we know that mu omega 1 minus omega 2 r square divided by h into 2 pi r into dr. If we simplify this equation and we again rewrite it, 2 multiplied by 2 pi mu omega 1 minus omega 2 divided by h into r cube dr. This is our dt equation. Now we will integrate this equation from t is equal to 0 to d by 2, means up to radius 2 pi mu omega 1 minus omega 2 divided by h r cube into dr. This is constant form. So we will 2 pi mu omega 1 minus omega 2 divided by h into 0 to d by 2 r cube into dr. Now this equation is our final equation. Now we will solve this equation into Python code. So I will write as, this is SCIPY dot integrate. It means that we will use this equation with the integration form, and this is same matplot.library.py plot for this plotting our function. So first we will say mu is equal to 0.38. this I will say this is 0.38 Newton second per meter square, and our n1 is equal to 1200 rpm, and n2 is equal to 1125 rpm, and our h means thickness is equal to 2 divided by 1000, because our whole unit is in meter system. So h is equal to 2 divided by 1000, and our r is equal to this 30 centimeter diameter. So our r is equal to 30 divided by 100, 300 divided by 1000. So whole unit is in meter. Now our W is equal to 2 multiplied by NP dot pi. This is omega 1. Omega 1 means, I will say this one, omega 1 minus omega 2 is equal to 2 pi n1 minus n2 divided by 60. So I will write as 2 pi multiplied by n1 minus n2 and divided by 60. And my A means this constant, this whole constant 2 pi mu omega 1 minus omega 2 divided by h. So A is equal to 2 multiplied by np dot pi multiplied by u multiplied by w and divided by h. Now we will integrate our function. So how to integrate? We will first define our function. Define function is equal to integration of x comma or r comma a, our constant, and we will say return when this function will be completed. What the function? This, I will say this whole constant is equal to a. So my this a is equal to this constant. So a multiplied by r cube, and this is our function is defined. Now we will integrate our function. So I is equal to quad, this is for integration, this is, I will write integration function comma 0 to this r, 0 to up to this r, comma argument is equal to a. So it will, a is equal to this argument. So this is our defined function. If I print this function and solve it, I will say my torque is equal to, I will say T, torque is equal to this T, and run it. So my torque transmitted, the torque transmitted by shaft is in Newton meter, Newton into meter. So this is my 18.98 Newton into meter. This is my this is e raised to minus 13 is my constant of what to say, numeric integration. So this is my 18.98 Newton into meter. So we here you can see that I had defined 2 is equal to h is equal to 2. So if I want to change different from 0.1 to up to 10, so how to do that I'll see in next code. Please watch this full video and share it and subscribe to my channel. Thank you guys.